Hi guys, so I made another one of these SCR circuits, same as the other one, exactly the same. Just have a 12 volt Zener with the 10K pot here in series with it to the trigger of the SCR, and that's it. Just got the motor sitting on it here so it doesn't fall off the bench, but let's see if I can get a shot in the underneath of it. You can see what it looks like. Here's the pot connections. The wiper goes to the Zener, and then the Zener goes to the trigger of the SCR, and then I have this side of the pot connected to the positive. Doesn't matter which side you connect, only one of them can be connected though. Whichever side you connect depends on which way you'll have to rotate it. And that's it. 12200 UF 50 volt cap. Seems to work pretty good. I kind of like that circuit because it's such a simple circuit, and with the pot it makes it really adjustable. So you can see here's the motor current going in, and it's pulsing right here, and here's the scope shot of it. Like these circuits here are not for good power output. This is like a pulsing circuit for fixing shitty batteries. That's what it's going to be good for lead acid. And I've done a lot of testing with this type of circuit to see which is better, the pulsing output or the continuous output. Like with this motor here, I've never showed this motor, but I've been testing a lot with it. Two identical circuits, one with the pulse output and the other one with continuous to the battery, just directly from the driver. It took forever to get these magnets in here. It wasn't easy to get those big strong magnets connected on the rotor. And like always, all my rotors are steel, ceramic bearings. And I can't stress enough how important it is to have your coils spaced properly with your magnets. Like these coils on this rotor don't work very good. They'll make it spin in that, but they're not nearly as efficient as these ones are. These are the coils, part of the core that are in these coils. They're exactly where they need to be on the magnets. Can't stress that enough when you're building a pulse motor, especially ones like this that have the north-south magnets. And these coils are in series, so they act as one coil. One coil is pulling on a magnet while the other one is pushing it away. And they have to be spaced properly. If you don't have them spaced properly, they'll just fight each other. Alright, so I just want to show here. So that's the voltage of this battery here that's being charged. That one's fully charged. So, and I have it pulsing pretty quick. It's getting about 200 milliamp pulses out, and it's using about 250 continuously. I use these gauges because you can actually see the pulses. Makes it easier just to like gauge things, even though they're not accurate. So now all I'm going to do is turn these pulses up to where the voltage is going to rise on the back spike, but it won't rise past 50 volts. It'll blow this cap up if I try to go over 50 volts. So okay, let's take a reading on the RPMs here first. How many hertz? It'll show up right here in the second line down. We'll see what that is when I take this power lead off. It's about 300 hertz. And that'll be about the fastest it's going to go right now, because if I actually turn the pulses down to where they fire faster with a less of a output, the rotor will speed up. In that situation, the input power stays pretty much the same. It doesn't vary too much, unless your timing's in a different spot. Then yeah, you're gonna see some variations on your input power, but if you get your timing where it should be, things aren't going to change very much. But now watch, that's pretty much picked up its speed again since I did that. I'm going to turn this up so it fires at a higher voltage in the cap. Going to turn it up to where it's going to pulse like 350 or 400 milliamps, somewhere around the 40 volt range. So there, now it's hitting 40 volts about. You can see it work, right? It's giving about a 400 milliamp pulse. And it's using about the same. And as you can see with these motors, it doesn't go like this much when it's dumping, the way these are designed. It's going somewhere around like at 300 hertz. It's in that 2500 RPM range. So now you can see it's using about the same power, a little bit less than it was before, not much. The pulses are just bigger pulses, but not as many of them. But let's see what the rotor's doing. See the speed of the rotor now. We'll see what the hertz are again when I take that off. 292 now. So it slowed down quite a bit, right? I have to take the power off because the frequency is trying to read all these pulses from the PWM. It didn't slow down much, but it, you know, it's because that voltage is climbing up to a higher voltage now, where that higher voltage is your back EMF, and it actually slows the rotor down. See, it does that for a bit until the rotor's at its speed where it levels out at speed, and then it smoothens right out. See, I'm turning up. I'm gonna bring it way down. You can see it's using a little more power. It's pulsing. At about 20 volts or so when it triggers it. You can hear it speeding up. It's still speeding up, but I'm going to check right now what the hertz are. It's back to where it was before, 298-ish. If I would have left it, it would have went up a bit more. So now I'm going to bring it to where it's like 50 volts before it pulses. There you go, it's getting to about 50 volts. That's about as high as I could put it. It's still using about the same power. And it's pretty stable. Now I'm going to take this off and we'll see how much it slowed down. 285. You can see it slows down quite a bit. The more you let the voltage climb on the output, it fights your rotor speed, power on the rotor. So you can either get the power to the battery at a higher voltage, which where you're using the potential voltage, or you can get it out directly on the rotor itself. This torque. But just wanted to make this quick video. These are awesome circuits, really simple. And thanks for watching. Also too, there's a couple other guys you guys should check out, like just off the top of my head, there's Mike Does, Meg, that's Sam. You can see him in some of my comments. He has some motors he's starting to build. I don't know if you guys can think of any other ones, just put them down in the comments. I'm sure they wouldn't mind some subscribers if you guys are interested in that type of stuff, pulse motors and radiant energy. Some pretty interesting stuff. But thanks for watching, guys.